All right, today we're learning about special pairs of angles, 3 types of angles. Okay, so 3 types of angles today. There will be a little bit of writing for the definitions, but not too bad. So we should be on page 479 in our books. In example 1, we're learning about the first type of angle. These are adjacent angles, and they're also supplementary. So in the last lesson, we learned about complementary and supplementary angles. Well, there's just another name for supplementary angles, and we call them adjacent. What does that mean? It means that they share a common side, and their measures add up to 180. And I know that because they're supplementary. So they share a common side, which would be the lines, okay, what you would see as the lines, and their measures add up to 180. All right, so I'll give you a minute to write down the definition and draw the little diagram, and then we will name the adjacent pairs of adjacent angles. Okay, so now let's name the pairs, okay? So I'm going to give you the first pair. I have angle 1, and remember we use our angle symbol, and angle 2, right? Because angles 1 and 2, they share the common side, and I know that they're supplementary because they both lie on the same line. Do you see that? Mm-hmm. Okay. Can someone give me another example, another pair? Justin?
Angle 4 and angle 3.
Okay, very good. 4 and 3, or you could say 3 and 4, either way. Angle 3 and angle 4. Okay, can anybody name another pair? We've got 4 altogether. Quentin?
Angle 1 and angle 4.
Very good. Angle 1 and angle 4. And what's my last one? Alicia? Very good. Angle 2 and 3. And I know, and of course, I don't know the measure of any of one of these angles, but if I did, then I could find all the other ones because using my rules of supplementary adjacent angles. Okay, so that's the first type of angle that we've learned, is adjacent supplementary angles. The second type of angle that we're going to learn today, they're called vertical angles. Vertical angles. This happens when 2 lines intersect. So this diagram looks very similar to example 1. When 2 lines intersect, the angles opposite each other. So now they don't share the common side. That's the difference. They're opposite each other are congruent. What does it mean for angles to be congruent? They're equal in measure. They have the same measure. Okay? So if you know what congruent means, you don't have to write equal measure. That's just for those of you who aren't sure what that means, okay? Vertical angles are opposite each other and they are congruent. All right, so let's start off by naming our pairs of vertical angles. All right, so I have angle 1 here. What would be its matching vertical angle? If they're opposite each other, it would be angle what, Kevin?
3.
Angle 3, very good. Angles 1 and 3, because the 2 lines intersect and angles 1 and 3 are opposite. And what's my other pair? Chris?
2 and 4.
Angles 2 and 4. So what this is saying is whatever angle 1's measure is, that's going to be angle 3. Angle 3's measure. Whatever angle 2's measure is, that's going to be angle 4's measure as well, because vertical angles have the same measure. They are congruent. All right, so if I know that the measure of angle 1 is 75 degrees, what's the measure of angle 3? Class? 75 degrees, because they're vertical angles, and vertical angles have the same measure. So if angle 3 is 75 degrees, what's the measure of angle 4? And how do you know? This ties back into example 1. What's the measure of angle 4? Chris?
180.
Nope. You're on the right track, but I already have angle 3 is 75. Or say?
25.
Nope. Doesn't add up to 100. What are angles 3 and 4? What did I just teach you in example 1? They are what type of angles?
They're supplementary.
They're adjacent supplementary. So if they share the common side, one, thank you, 1 is 75 Angle 4 is going to be 105 degrees. Now, this is not drawn to scale, so don't say, oh, well, that doesn't look that much bigger. Okay, just use your imagination. Okay, angles 3 and 4 are adjacent supplementary, so they have to add up to 180. Well, if angle 4 is 105, what's angle 2? 105, right? Because it's vertical to angle 4. Do you see that? Do you see how it kind of ties together? Okay, all right. If not, just stick with me. Okay, hang in there. Well, hopefully you'll catch on in the next example. Okay? All right, so if I know one angle measure, I can find them all. Let's go ahead and move on to our third type of angle. Corresponding angles. You need to know a few things first, okay? First of all, a plane is a flat surface that has no end, okay? So basically, I'm looking at how lines basically relate to each other within a plane, okay? So that's going to be the flat surface that has no end. Then you have parallel lines. What are parallel lines? They're two lines in the same plane that never intersect. And they usually have an arrow type of figure drawn like this to show that they are parallel. Okay, I know that's not the best drawing, but it's like an arrow like that. And that shows that they're parallel as well, so you don't have to guess. And the symbol for parallel lines, and you need to know this, it's like an 11. It looks like an 11. But it's always going to be bigger than the rest of whatever you're comparing. So the parallel lines, they just stick up a little bit higher, and you'll see that in a minute. Then you have perpendicular lines. Perpendicular lines are two lines that intersect, again, in the same plane. Okay, so they're not perpendicular unless they actually intersect in the same plane, in a plane. All right, not that they look like they're going to intersect, but that they actually do. And the symbol for perpendicular lines is an upside down T. All right, so make sure you write down the definitions and the symbols. You don't necessarily have to draw the pictures. All right, so now let's move on to actually what is a corresponding angle. So you need to know parallel and perpendicular lines in order to understand what this definition means. When 2 points are located at the same position on 2 parallel lines, they are congruent, okay? And this is what this means. Let's just go ahead and, all right, so everybody agree that the first one is not parallel, right? Because it doesn't intersect, okay? It doesn't intersect there, but I know it's going to, right? Okay, so, but these lines are parallel. So if I had these angles labeled, 1, 2, 3, 4, 5, 6, 7, 8, okay? This is what corresponding angles say. If the lines are parallel, and they have to be parallel, whatever the measure of one angle is, let's say it's 72 degrees. In the same position on the other line, the measure will be the same. So, which angle is in the same position as angle 2 on the other line?
6.
Angle 6. So, corresponding angles say if their lines are parallel, then angle 6 will have the same measure as angle 2. Make sense? Okay? And now if angle 2 is 72, what would angle 4 be? Vertical, right? Angles 2 and 4. There would be vertical angles, right? And vertical angles have the same measures. So angle 4 would be 72. If angle 4 is 72, what would angle 8 be? 72. What about angle 7?
Oh, whatever,
There.
whatever 72, it adds up to 180.
Okay, because angles 7 and 8, that's our first type of angle, the adjacent supplementary. So 180 minus 72 gives me the measure of angle 7. You see how I start filling these in?
So it's 108,
Okay, so what about angle 5?
108.
Tabitha, what about angle 5?
108.
108, because it's vertical to angle 7, or supplementary to angle 8, or angle 6. Okay, now if angle 5 is 108, then that means angle 1 is 108. If angle 1 is 108, what does that mean angle 3 is?
108.
108. You see how that all that kind of fills in?
Yeah.
Okay, so it all comes together. It all comes together whenever I'm looking at two lines that are parallel and have an intersecting line in one plane. I can use all three of the types of angles that I learned today: adjacent, vertical, and corresponding angles. All right, last but not least. Okay, now this is example 3 in your book. If I can pull it up. There we go. All right, in example 3, you don't have to draw the diagram because it's right there in your book. So just look with me on page 483. Page 483. Do not have to draw this. Okay, the first part of it says, name 2 streets that are parallel and 2 streets that intersect. All right, so someone raise your hand and tell me, what are 2 streets that are parallel? One pair. What's one pair of streets that are parallel? Kevin?
Street and Main Street.
Hold on. Sorry, wrong page. Page 481. Page 481. That diagram under example 3. Okay, so try again, Kevin. What would it be?
34th Street and 23rd Street.
Very good. 34th and 23rd. And notice that my parallel symbol is taller than my letters. Okay, so just make it a little bit taller. What's another pair of parallel streets, Quentin?
7th Avenue and Park Avenue.
Very good. 7th Avenue and Park Avenue. Now the intersecting streets, there's a lot of them. So just name me one. What's one pair of intersecting streets, Chris?
7th and 23rd.
Okay, 7th and 23rd. What's another one? Come on, not everybody at once. Alicia?
Is it 34th and Park?
34th and Park. What's another one? Kevin?
7th Avenue and Broadway.
7th and Broad? No. Those don't intersect. Not on that plane, they don't intersect. They will eventually, but they don't intersect on that plane. Justin?
7th and 23rd.
7th and 23rd. Okay. What about Broadway? What does Broadway intersect with? Chris?
Broadway and 34th.
Okay, Broadway and 34th and Broadway and 23rd too. Okay, so just name any 2 of them. Okay, and remember that upside down T shows that the streets are perpendicular. Okay, do you see that? So we named a couple parallel and parallel and intersecting streets. All right, now let's look at example B. Given that the measure of angle 7, and I just fixed that angle sign. I don't know why it messed up again. Given that the measure of angle 7 is 68 degrees, find the measure of angle 1. All right, so I know angle 7 is 68 degrees. What is the corresponding angle to angle 7? What is the corresponding angle to angle 7? Alicia?
5.
Not angle 5, that's a vertical angle. Angle 7. So corresponding would be on the other intersecting point, same position. Kevin?
6.
No.
No.
Justin?
3.
Angle 3. Very good. So if they're parallel, which I know these lines are, what would be the measure of angle 3? If they're corresponding? It would be 68. They would have the same measure. Well, if angle 3 is 68, what's angle 1?
68.
How do you know that?
Because they are vertical.
Because they are vertical. So now I can answer the question. The measure of angle 1 is 68 degrees. Okay, but I'm not done yet. All right, if angle 1 is 68 degrees, I can figure out all the rest of them.
Yeah.
What would angle 4 be? How would I figure that out? What type of angle is that?
6. Some the S.
It's an adjustment.
Okay, yes, they're supplementary adjacent. Okay, so angle 4, I guess I didn't write the rest of this. Angle 4 would be 100 and what? 180 minus 68 is 112?
Yeah, 112.
112? Okay, what would angle 2 be?
112.
112 because it's vertical. All right. Well, if angle 2 is 112, what's angle 6?
112.
112. Why? What type of angle is
It's
it?
vertical.
No. Corresponding. Angle 2 is in the same position as angle 6, just on different intersecting points. Well, if angle 6 is 112, what's angle 8?
112.
112, and what type of angle is that?
Vertical.
Vertical. And what would angle 5 be?
68.
68, because it's vertical to what angle?
7.
7, or it's adjacent to angle what?
1.
Adjacent.
Oh,
Angle
4.
6, it's adjacent, shares a common side, or it's adjacent to angle 8 too, because it shares a common side with that one too. So you see how it all kind of comes together? All three. So what do you need to remember from this lesson? Adjacent angles are supplementary. They share a common side and add to 180. Vertical angles are opposite, and they have the same measure. Corresponding angles can only happen if there's two parallel lines. If they're parallel, same position on two different parallel lines, they'll be the same measure. Okay, so you need to remember those three types of angles. And that's everything you need to know for 10.2.